hi everybody. I suppose the concept of maxima minima is well understood by all of you, and I promised that I will tell you something about the word problems of maxima minima. So I have come up with the video for the word problems or the practical problems of maxima minima. By this we can understand what is the use of derivative in our practical life. You have already got it from the introduction part. I hope you all are enjoying my video and getting a lot of benefit from it. If not, if you require any type of modifications in my video or any more information you would like, then please do not hesitate to inform me through the comment box. I will surely help you. If you have any other doubts, please write. I shall try my level best to solve your problems. So let us move on with the problems. Find two numbers whose sum is 15 and the sum of whose squares is minimum. Minimum we have to show. So let S denote the sum of the squares. S is x square plus y square. So we can write from here, from number 1, x square plus 15 minus x the whole square. That is x square minus plus 225 minus 30x plus x square, or that is 2x square minus 30x plus 225. We have to find out the sum of the squares is minimum. So ds by dx, we find 4x minus 30, and at maxima minima ds by dx should be 0, or 4x minus 30 should be equal to 0, or x should be 30 by 4. So we have to check whether this x is equal to 30 by 4, that is 15 by 2, will give minimum value or not. So for that, let us find d2s by dx square, that is 4. Now this is 4 which is greater than 0 at x 15 by 2, because at 15 by 2 also it will be positive because there is no x, so the value remains positive at any case. So this is greater than 0, shows S is minimum at x is equal to 15 by 2. Then y is, therefore y is 15 minus 15 by 2, that is also 15 by 2. Therefore the numbers are 15 by 2 and 15 by 2. So that is 7.5. 7.5. So the positive numbers are 7.5 and 7.5, whose sum of the squares will be minimum. Let us see the next question. A right angled triangle with constant area is given. Prove that the hypotenuse of the triangle is least when the triangle is isosceles. So our question is, in a right angled triangle, for a given area, we have to find that the hypotenuse is minimum, or we have to prove that the hypotenuse is minimum if the triangle is an isosceles triangle. So I have considered the triangle ABC right angle triangle with L as the hypotenuse. So A is equal to, and theta is the angle made by the base and the hypotenuse. So the expression for the area is L half base into altitude. This will be L cos theta. This will be L sin theta. So further calculating, we get half L square cos theta into sin theta, or A is equal to L square by 4. 4 because I multiplied by 2 in the numerator and 2 in the denominator. So it comes sin 2 theta. So 4A by sin 2 theta is L square, or 4A cosec 2 theta. Now L will be minimum if L square is minimum. So if we can prove that this part is minimum when the triangle is isosceles, then our proof is solved. So let this be a function of theta, that is 4A cosec 2 theta. So we have to find out the first order derivative, that is minus 4A cosec 2 theta cot 2 theta into 2, that is minus 8A cosec 2 theta cot 2 theta. So for maximum minima, for maximum oblique minimum, f dash theta is 0. F dash theta is 0 means minus A cosec 2 theta cot 2 theta is 0 minus 8A. So this portion goes below 0, so it is 0. So cosec 2 theta is 1 by sin 2 theta, and this is cos 2 theta by sin 2 theta, that is 0, or cos 2 theta 0. This shows that if cos 2 theta is 0, that means 2 theta is pi by 2, or theta is equal to pi by 4. So we have got theta pi by 4. Now for this pi by 4, I have to check by finding out the second order derivative whether this gives a positive value. If it is positive, then for theta is equal to pi by 4, we will have the minimum or the least hypotenuse. So let us find out the second order derivative, f double dash theta, that is minus 8A cosec theta cot 2 theta, that is u into v cosec 2 theta. Derivative of cot 2 theta is cosec square theta minus cosec square 2 theta into 2 plus derivative of cosec theta is minus cosec 2 theta cot 2 theta into 2 into cot 2 theta. So when we put pi by 4, you can calculate and see that cosec pi by 2 into minus 2 cosec square pi by 2 plus then minus 2 cosec pi by 2 cot pi by 2. We will see that this will give a positive quantity. If I calculate, this will give a positive quantity, or this is more than 0. Hence, for pi by 4, the expression is least. If the expression is least, and theta is pi by 4, that means this angle is also pi by 4. And if these two angles are pi by 4, then this becomes an isosceles triangle. Let us see the next question.
An open tank with a square base and vertical sides is to be constructed from a metal sheet so as to hold a given quantity of water. Show that the cost of material will be least when the depth of the tank is half its width.
So our question is, we are given an open box with square base. Square base means the length and breadth is equal, and given volume means we can the tank, open tank, this is not box, to open tank, it can hold a given quantity or given capacity of water. That means this V, the volume of the tank, is known to us. So what should be the material required so that the cost is minimum? Now, in order to have the minimum cost, the surface area should be minimum. So we have to understand in that way. So in order to have the minimum cost of material, the surface area of this open tank should be minimum, provided the tank holds that much volume of water, which the volume is given. Now I have considered the base as x and y, and the height to be y. X, the base we have considered xx, and the height to be y. So the volume will be x square y, as I have written, you can understand from here. So y is equal to v by x square. Now what will be the surface area? Let the surface area be A, that is base area is x square plus 4 walls, that is 4xy. 4xy. So this is x square plus 4x into v by x square, or x square plus 4v by x. Now let us, since this is a function of x, let us write a as function of x. A is a function of x. So our derivative will be f dash x equal to 2x minus 4v by x square. So for minimum surface area, for maximum or minimum surface area, f dash x is 0, or 2x minus 4v by x square is 0, or 2x cube is equal to 4v, or x is equal to cube root of 2v, or we can write 2v to the power 1 by 3. So this is the value of x. Now I have to check whether for this value we get the minimum surface area. So f double dash x we have to find. So f double dash x is equal to 2 plus 4 into 2v by x cube, or 2 plus 8v by x cube. Now this will be obviously greater than 0 for x is equal to 2v to the power 1 by 3 implies A is minimum or x is equal to 2v to the power 1 by 3. So A is minimum for x is equal to 2v by x cube. 2v to the power 1 by 3. So putting the value of x here, we'll get v by x square, that means 2v to the power 2 by 3. That is v to the power 1 by 3 2 to the power 2 by 3. That is y equal to 1 by 2 v to the power 2v to the power 1 by 3. So we see that y is half of x, because this is x. Hence, the depth is half of the width. Let us see the next question.
A window is in the form of a rectangle surmounted by a semicircular opening. Total perimeter of the window is 10 meter. Find the dimensions of the window to admit maximum light through the whole window.
So this is the shape of the window. We have a semicircle on the top with a rectangle. Perimeter of the whole window is 10 meters. So perimeter of the semicircle plus perimeter of the rectangle. So we will have only the outer portion perimeter of the semicircle, because this is not considered. Only the outer length of the window will be the perimeter. The curved portion of the perimeter of the semicircle and this three portions. So we will have pi x plus 2x plus 2y, and you subtract this length. So this is, because if I take the rectangle perimeter, then we are taking this also. So minus 2x, or it is pi x plus 3x of 4x plus 4y minus 2x, that is pi plus 2x plus 4y, or y equal to 10 minus pi plus 2x divided by 4. Now we have to show that maximum light passes through. That means the area should be maximum. So area is given by pi r square by 2 plus length into breadth, that is 2x into 2y, that is 4xy. X instead of x, r it will be x. So a is pi x square by 2 plus 4x, y is 10 minus pi by plus 2x divided by 4. So this 4 cancels. So a is pi x square by 2 plus 10x minus pi plus 2 x square. I hope you are understanding. So this is the area. Now we have to find the derivative. dA by dx, that is 2 into pi x square by 2, that will be pi x plus 10 minus 2 into pi plus 2x. For maximum or minimum light to pass through, this will be for maximum or minimum, this will be 0, dA by dx is 0, or pi x plus 10 minus 2 pi plus 2 x is 0, or x, you take bracket in common, pi minus 2 pi minus 4 plus 10 is 0, or x minus pi minus 4 is equal to minus 10, or x is equal to 10 by pi plus 4. So the radius we have got, hence the dimension of the whole window could be calculated by putting the value of x here and getting y. That is 10 minus pi plus 2 x. X is 10 by pi plus 4 divided by 4. So y we will get from here, calculating it. Then we have to find out d2y by dx square. So after calculating, we get y is equal to 5 by pi plus 4. If you calculate, you will get this. Now dA by dx was pi x plus 10 minus 2 pi plus 2x. Now if I find the second order derivative, d2a by dx square, you will get pi minus 2 pi plus 2, or this is minus pi minus 4. So this is obviously negative for any of the values at x is equal to 10 pi plus 4. So negative means maximum. So implies A is maximum. Hence Ax is 10 pi plus 4, that is the radius of the semicircle will be 10 pi plus 4, and length will be 10 into 2, 20 by pi plus 4, and width will be 10 by pi plus 4. 5 into 2, 10 pi plus 2 meters. This is also meters. This is the radius. I suppose the question has been understood by all of you. This type of questions usually are asked in both the boards, CBSE as well as ISC. You can have questions based on numbers, or you can have questions on the solid geometry or plane geometry. Any doubts, any clarification, I again remind, please comment, like, share, subscribe. Thank you. See you again. Bye bye.